Hey there, StudyBuds! I'm your StudyBud Glenn, and we're back again with another video. Now that we've already finished discussing the basics of trigonometry from our last video, we will now proceed to a new topic, the 6 trigonometric ratios. How fun is that? Let's go! Trigonometric ratios are defined as the values of all the trigonometric functions based on the value of the ratio of sides in a right-angled triangle. These 6 trigonometric ratios might be familiar to you. You may have seen them in your calculators back in math class. These are the sine, cosine, tangent, cosecant, secant, and cotangent. Now let's define each of them. The first trig ratio is the sine function. Usually denoted with this abbreviation, it is the ratio of the length of the opposite side divided by the length of the hypotenuse. Next, we have the cosine function. It is defined as the ratio of the side adjacent to that angle to the hypotenuse. We also have the third trigonometric ratio, which is the tangent function. This ratio is defined as the ratio of the side opposite to that angle to the side adjacent to that angle. The cosecant is the multiplicative inverse of the sine function. Basically, the multiplicative inverse is the reciprocal. That means the cosecant is the reciprocal of the sine function. So, it is basically the ratio of the hypotenuse to the opposite side, while the second function is the multiplicative inverse of the cosine function. That means it is the ratio of the hypotenuse to the adjacent side. And lastly, we have the cotangent, which is the reciprocal of the tangent function. That means the cotangent is the ratio of the adjacent side to the opposite side. For triangle ABC, the ratios are defined as the sine of C, which is the side opposite to angle C divided by the hypotenuse, is equal to the side AB divided by the side AC. The cosine of C, which is the side adjacent to angle C divided by the hypotenuse, is equal to the side BC divided by the side AC. The tangent of C, which is the side opposite to angle C divided by the side adjacent to angle C, is equal to the side AB divided by the side BC, which is also equal to the sine of angle C divided by the cosine of angle C. The cosecant of angle C is just the reciprocal of the sine of C, which is the hypotenuse divided by the side opposite to angle C, is equal to the side AC divided by the side AB. The secant of C, which is the reciprocal of the cosine of C, also the hypotenuse divided by the side adjacent to angle C, is equal to the side AC divided by the side BC. The cotangent of C, which is the reciprocal of the tangent of C, which also means the side adjacent to angle C divided by the side opposite to angle C, is equal to the side BC divided by the side AB. So we can summarize them using this mnemonic device, SOHCAHTOA. So stands for sine is equal to the opposite side over hypotenuse. Ka stands for cosine is equal to adjacent side over hypotenuse. TOA stands for tangent is equal to the opposite side over the adjacent side. And for the remaining ratios, just find the reciprocal of each. So cosecant is equal to hypotenuse over the opposite side, secant is equal to the hypotenuse over adjacent side, and cotangent is equal to the adjacent side over opposite side. So you can extend SOHCAHTOA and make it SOHCAHTOA CHOSHAKAO. So when the mother of Sokatoa is angry, expect to hear Sokatoa Choshakaw. That lang. Now that we have already discussed the definition of the 6 trigonometric ratios, we need to know how to evaluate the trig ratios of different angles without depending on our calculators. Let's begin with the special angles 30 degrees, 45 degrees, 60 degrees, and 90 degrees. Remember that all trigonometric ratios of an angle remain constant regardless of the lengths of the sides involved. And with that, let's have the following right triangles as our basis. The 30, 60, 90 triangle and the 45, 45, 90 triangle with the hypotenuses both equal to 2. We use that value because it's the most convenient when we apply the trigonometric ratios. If we use the side relationship x is to x squared of 3 is to 2x for 30 is to 60 is to 90 triangle, we find that the missing sides are 1 and square root of 3 opposite to 30 and 90 degrees respectively. If we use the side relationship x is to x squared of 2 for the 45, 45, 90 triangle, we find that the missing sides are both equal to square root of 2. Now that we have these, are you ready to find the trig ratio, StudyBuds? Let's start with the sine of 30 degrees. Remember that sine is equal to opposite over hypotenuse. So from the 30, 60, 90 triangle, the opposite over hypotenuse of 30 degrees is equal to 1 over 2 since the opposite side is 1 and the hypotenuse is 2. Therefore, sine of 30 degrees is equal to 1/2. That is always true regardless the size of the triangle you're using. Then the cosine of 30 degrees, which is adjacent over hypotenuse, is square root of 3 over 2. Similarly, that's always the value of cosine of 30 degrees. Now the tangent of 30 degrees, the opposite over adjacent, is 1 over square root of 3 or square root of 3 over 3 when we rationalize the denominator. If you're going to do the same process for the angles 45 and 60 degrees, we can construct the following table of trig ratios. And this is very important in our study, so make sure to be familiar with them. Remember that these ratios remain the same no matter what. But how about the trig ratios for 90 degrees? Let's try. The sine of 90 degrees, opposite over hypotenuse. Wait, what? If it's 90 degrees, the opposite side and the hypotenuse are the same? Yes, they are the same. But don't worry, just follow the rules. So sine of 90 opposite over hypotenuse is 2 over 2 or simply 1. And that is correct. That is always the value of sine of 90 degrees. It's always 1. How about the cosine of 90 degrees? The cosine of 90, which is the adjacent over hypotenuse, is... Wait, what? What's the adjacent side now? The two sides are possible adjacent sides, right? Since we are still confused with which is which, for now, we let our adjacent be equal to 0. So, cosine of 90 degrees becomes 0 over 2 or simply 0. That's actually always true. Cosine of 90 degrees is always 0. It may sound confusing now, but when we discuss these analytically in the future, everything will make sense. For now, just remember that cosine of 90 degrees is equal to 0. How about the tangent of 90 degrees? Okay, we are here again. Tangent of 90 is opposite over adjacent to the 90 degree angle. We know that the opposite side is 2, but what is the adjacent side? This is the same dilemma we had for the cosine of 90 degrees. And in order to solve this, let's use the partial solution we had for cosine of 90 degrees. We allowed the adjacent side be equal to 0. That means the tangent of 90, which is the opposite over adjacent, is 2 divided by 0. But that's undefined. Are you kidding me? No, I'm not. Tangent of 90 degrees really is undefined. Note that when there's a 0 in the denominator, that means it's undefined. So we can now really complete our table. This is it. Yeah. So be familiar with these StudyBuds. This table will serve as your weapon in fending off the troubles of problem solving in trigonometry. There are two things that you need to remember from this video. The table we made and Sokatowa Choshaka. And that's it for today's lesson on trigonometry, my dear StudyBuds. We hope that you learned something today. This has been your StudyBud Glenn reminding you to study well. Till our next trip to Study World, StudyBuds.